Hi, this is Accelerated Geometry, Section 10.4, Circles and the Pythagorean Theorem. Today we're going to do Accelerated Geometry 10.4, Circles and the Pythagorean Theorem. So this is kind of a complicated section because it's everything about circles and that you know and everything about the Pythagorean theorem that you know all coming together in these problems. So it's going to be a little tough. To start out, they do a little review of conjectures. Tangent to a circle is perpendicular to the radius drawn to the point of tangency. Remember that? So here is a tangent, and here's a radius drawn to where that point of tangency is that always creates a right angle. So that's just something to remember as you do the homework problems. Angles inscribed in a semicircle are right angles. So here is a diameter, so that creates two semicircles, one over here and one over here. And if I have an inscribed angle in there, so it touches the circle here, the inscribed angle is always half of its intercepted arc. So if the intercepted arc is 180 degrees, then this inscribed angle is always going to be 90 degrees. And in an equilateral triangle, where all the sides are equal, remember, the altitude, so this line is an altitude, it comes down perpendicular to the opposite side. The angle bisector, this is this line that cuts this angle here in half into two equal parts. And the median, it's the same line, comes down to the midpoint of the opposite side. So in an equilateral triangle, the altitude, angle bisector, and median from a vertex are the same segment. Medians intersect at the centroid so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. Okay, so a median goes from a vertex to the midpoint of the opposite side. From a vertex to the midpoint of the opposite side, from a vertex to the midpoint of the opposite side. They meet right here at the centroid, and the distance from the centroid to the midpoint here, if this was 2, this is going to be double that, or 4. So that's a review of that one. So now we're ready for example A. There are 2 examples. If OC is perpendicular to AB, so right in there, there's going to be perpendicular mark, a 90-degree angle mark. And AB across here is 24, and MC over here is 8. Find the diameter of that circle. Okay, so here they say, if AB is 24 across here, then halfway across from A to M is going to be 12. So that's how they get the 12. Okay, this is a chord in the circle, and this is a radius drawn in there, so that creates a 90-degree angle. And they say we know that this piece here is 8, and we don't know what this upper piece is, so they call it x. But now look, that radius, this is a radius here, is x plus 8. So every radius in the circle would be x plus 8. So I now know that piece. So this here is a right triangle, and its sides are x and 12 for the legs, and the hypotenuse is x plus 8. So now we can use the Pythagorean theorem to figure out what x is. So they said x squared plus 12 squared is equal to the hypotenuse of x plus 8 squared. When I square x plus 8 times x plus 8, I get x squared plus 16x plus 64. That's a mistake that is often made in algebra class. A lot of kids will say, oh, this is x squared plus 64. It's x plus 8 times x plus 8. That's what the square means. So I have x squared plus 8x plus another 8x. So in the middle there I have plus 16x, and then I have plus 64. So be careful about that. And then here I just have x squared plus 144. There are x squareds on both sides, so we can subtract those off. So that gives us 16x plus 64 is equal to 144. Subtract 64 to get 16x alone and 80 on the other side. And divide by 16, I get x is equal to 5. So therefore, if x is 5, and this piece here, MC, is 8, then the radius is 13, which means that the diameter would be twice that, or 26. So there's a lot of thinking that goes into these problems, and you have to know a whole lot of stuff, so it's kind of a triumph when you get it correct. Okay, here's the last example. It says HA is 8 square root of 3. So here is 8 square root of 3. Find the shaded area. Round your answer to the nearest tenth. Okay, so here's their plan. They said this side here is 8 square root of 3. This is 120 degrees, so what we're going to do is we're going to put an extra line in here that cuts right down the middle, making this be 60 and 60. So that's how they get this as 60 degrees. And remember, a radius drawn to a tangent forms a 90-degree angle, so that's how they get the 90-degree angle in here. So I have a 30, 60, 90-degree triangle. In a 30, 60, 90-degree triangle, if the side across from the 30 is unknown, which it is here until I find out it's 8, and if the side, if I call that A, then the side across from the 60 is A square root of 3. If this is A square root of 3 and it's 8 square root of 3, then A must be 8. So that's how they got that this over here is 8. So now what do I know? I know this side is 8. I know this side is 8 square root of 3. So that's how they're finding these. So what they're going to do here is they're going to find the area now of that whole half of the section, so of this area, of this, the area of this triangle. And then they're going to subtract out this pizza slice, that sector. So that's what they're saying here. They're going to subtract out the sector, the slice of pie, the slice of pizza, and what I'm going to be left with is this piece up here. And then I'm just going to double it to find out what the total shaded area is. Okay, so they start. The area of the triangle is 1/2 times the base times the height. Bases and heights meet at 90-degree angles. So they would be 8 and 8 square root of 3. So half of 8 is 4. 4 times 8 is 32. So 32 square root of 3 is the area of the whole triangle. Then we're going to find the area of a sector. Remember, a sector is a fraction of the area of the whole circle. So the whole circle would be pi r squared, pi times the radius of 8 squared, but I only want a fraction of it, 60 degrees out of the whole 360. So they reduce that to 1/6, and then pi, and then 8 squared is 64, and then they do a little canceling by dividing by 2 on the top and the bottom, and they get 32 pi over 3. And now they're going to say that shaded section just on the upper part is the triangle minus the sector, but we're going to have 2 of them, this piece here and this piece here. So that's where they get the 2 from. They're going to take twice now the subtraction of the triangle's area and the sectors. So here's the triangle, here's the sectors. And then they do a little bit of algebra. See how this has a 32 and this has a 32? So they factor that out to the front. So 2 times 32 then is 64, and then they leave that like that. I suppose if you had just multiplied this by 2 and this by 2, I, of course, would have given you credit for that. But if you want to get the same answer they have in the book, that's what they did. So the shaded area then, if I put that in my calculator, is 43.8 square centimeters. So that is this lesson, which, as I said, has some difficult problems in it. So be very joyful when you get the answers and very proud of yourself when you get each of the problems correct. If you don't get them correct, look at the solutions manual. If you're really stumped, send me an email and I'd be happy to answer you. Hope everything is going well for you. Bye.